Hocam merhabalar, hoş geldiniz.
Evet.
Nasılsın?
Çok mersi, çok mutlu olduk gelişinize. Tekrar sözü Atakan'a bırakıyorum. Teşekkürler.
Ben başlamadan kısa bir tanıtayım isterseniz size. Arkadaşlar ikinci oturumumuzda Tuğrul Daim ile beraberiz. Kendisi Boğaziçi Üniversitesi Makine Mühendisliği mezunu. Şu anda da Portland Üniversitesi'nde öğretim görevlisi olarak devam ediyor. Ve bugün bize dijital dönüşüm hakkında bir konuşma yapacak. Tekrardan teşekkür ederiz geldiğiniz için. İsterseniz ben mikrofonu ve kameramı kapatayım. Size bırakayım. Başlayalım.
Tamam. Benim ekranımı görebiliyor musunuz?
Evet, görüyoruz.
Konuşma İngilizce olacak yalnız. So, good evening to all of you over there in Istanbul, and it's good morning here. It's about 9 a.m. here in Portland. This is Portland, Oregon, the Pacific Northwest of the United States. Like in the introduction, I'm a professor here at Portland State University, and I'm also the director of the Technology Management Doctoral Program. Just a little about me before I basically tell you about evaluating technologies for digital transformation. I have a PhD in engineering, system science and engineering management, and then degrees in mechanical engineering, bachelor's and master's. And then I worked for Intel Corporation for over a decade after when I decided to come back to the academia. And I've been basically a full-time faculty since 2005 and have been a full professor since 2014. And during my tenure at PSU, I worked with the Department of Energy for over 15 years. Actually, I had an office there. And a big part of the presentation today had its roots from that experience as well. So we worked with them to evaluate and plan for the digital transformation in the power transmission sector. Of course, we're going to talk about how priorities and whatnot change these decisions throughout the presentation. And then when the Obama administration was replaced by the Trump administration, all our work with DOE had stopped because there were no more interest in getting into the digital age by this administration. And then we just started again getting funding to look at new technologies, so that indicates that priorities are changing as the new administration are coming in. So in addition to that, you're going to see throughout this presentation the foundations of my research group. So I've been leading a research group on evaluating technologies, and we have had 23 PhD students out of this group, and this is really based on their work, what I will present today. And I have currently about 20 students working in my group. I'm also the editor-in-chief of IEEE Transactions on Engineering Management. So that's one of the top journals that's been in the field for over half a century. And that's really looking at the academic work in this area. And then through my PhD group, I am active in basically research and publishing in this area. And if you're interested, I could send you the papers that this presentation is based on, and what you're going to see throughout this presentation is published in different venues. So digital transformation. So we have a lot of buzzwords, and buzzwords come and go. And I've been in this area for now over 3 decades. And I've seen the fundamental concepts named as different things. But what we need to understand is what's really happening, what's underneath. So my advice to you, the students, is to not to focus on buzzwords, but understand the buzzwords because that's what industry focuses on, but understand what's really fundamental. Now, I'll give you a few examples. Back when I was a student, we had a big buzzword, total quality management. What it was is really quality control and statistical process control. But it was a good buzzword for the industry, and industry picked up on quality control. In the last decade, we have had data analytics, as you all know. But what it is it's really operations research and statistical analyses. Now, of course, these are these methods are empowered with the new technologies today, but again, understanding the underlying information is very important. And digital transformation is a good one too. But what's happening here is we see every industry is being intersected by technologies, and mostly information technologies. And the challenge here I'm going to talk about is how to get the right technology, how to acquire or how to select the right technology to acquire. And frankly, I've been doing this type of research for about 30 years now, acquiring technologies. Now, when we started, we were looking at electronics manufacturing companies acquiring, because they had to acquire technologies, not the baker shop or not the healthcare, not the energy. It was not there, or not sports, right? Today, now every basically sector has to acquire technologies to have a sustainable future. So this is what really I talked about in the beginning, right? So all industries, all sectors have to do that. Now, but how will they do that? How will they evaluate technology? So this is what we will talk about. Now, evaluating technologies is not just looking at technical aspects. There are multiple aspects, and that's what you will see throughout the presentation today. And for example, a lot of times we look at technical and economic and we ignore social, environmental, or political, whereas those are really important. I'll give you an example from here in the Pacific Northwest, the importance and what happens when you don't do that. So we have here in the Northwest a very mixed culture, or very rich culture. We have indigenous people, that's the Native Americans living, and they are really, their life dependent on, in some areas, on water and what they get from water. And what we have in the Northwest is wild salmon. It basically is in the rivers, and that's a part of their culture. Now, of course, other thing we have here in the rivers are dams. We have a huge river coming from Canada down here to Oregon through Washington, which is Columbia River, and it's dammed, and it is, as a result, this area has the highest hydropower in the United States. Now, the fish and the dams do not get along well, as you can imagine. And of course, you have the social aspect with the tribes. So the Bonneville Power Administration, which is a part of U.S. Department of Energy here in the Northwest, is responsible for managing the dams, really, and transmitting and marketing the power through them. However, they had to work with the tribes, and they had to manage the biggest wildlife program in the whole United States. So as you can see, a power company has the biggest wildlife program in the whole country. So that means they cannot just focus on technical aspects. The reason why they have this program is they had to build passages in the dams so that the fish can go through. Now, as a result, the fish will not die, right? Now, There are some, of course, has been challenges. While they were able to look at one perspective, they had ignored some other perspectives, right? In the spring here in the Northwest, the snow melts, and then there's a lot of water in the rivers. Now, another aspect of our region is its attention or its priority of renewable energy, but without really understanding, again, multiple perspectives. So over a decade ago, or more than a decade ago, the region basically said, okay, come to our region, put your wind plants, wind farms, and we commit to buying everything you can generate, right? Now, as a result, even foreign companies came, Spanish companies like Iberdrola. And what happens in the June when we have a lot of water in the rivers, we cannot let it go over the dams because that will kill the fish. So we then open the dams, the fish goes through the passage, and we generate power. So as a result, we don't need the power from the wind farms. And then, however, because we committed to them, we pay for the power they never generate with the US dollars or with the taxpayers' dollars, right? So again, these are some examples showing you that you need to look at multiple perspectives when making decisions to acquire technologies. Otherwise, you can basically really have negative results at the end. So let's talk about the theory behind this. Okay. So we have initiated an institute here looking at these emerging technologies when Obama administration prioritized energy about 12 years ago. And we said we're going to look at these multiple perspectives from technical to political, and each having basic criteria underneath that. Now, this really approach is developed by Professor Rnd Kokaglu, who was my advisor when I basically was a student. And this is more than 2 decades ago. And it really looks at the problems through an hierarchy and calculates the weights at every level and uses what we call desirability functions. Now, desirability functions is really has 2 objectives. One is to really normalize the values. I mean, when you look at things such as efficiency, capital costs, also quantify things like aesthetics and job creation type qualitative factors. Also, to really help us to assign a value that will be meaningful for our organization. Because the costs can keep going up, but after one point, it doesn't matter to us. It will be always zero because after a certain point, beyond our budget, it will not mean anything to us. And the same way, after a low point, beyond a low point, it will be always good to us, right? So that's why we create these value curves after which they can be asymptotic, and that will help us to really measure the value for our organizations. Now let's go through these applications which will then help you to understand. Now, each time I will mention what this application was for, funded, where it was basically published. So this was based on the dissertation by Dr. Ishkin. He was one of my students, and this was published in a journal, as you can see, and sponsored by several funding sources, including Bonneville Power, Miller Foundation, and Massey Foundation. And then what we did was we looked at energy efficiency program planning. Now, what is energy efficiency? Okay, just real quickly, when there is a high demand for power, the things you can do is add new power plants or start energy efficiency program. So energy efficiency program is like an alternative to adding a new power plant. Now, however, just adding a new technology will not bring you those energy efficiency savings, right? So you need to be developing programs that will help you measure these savings consistently, and they should be adopted. So these products should diffuse in the market, should be adopted so that the savings can be realized. And the energy efficiency programs can include lighting, energy efficient lighting, through the basically the power savings we have in our computers, laptops, and so on and so forth. Now, when we developed this model, when we looked at this is what became these two columns through the literature. And when we went to the experts, they basically told us, well, you cannot really realize any savings without understanding program development and market dissemination. So we expanded the model. Now, how do we measure, or how do we come up with the value? So I did not talk about that in the beginning. Now, this approach is also known, or similar approach is also known as analytical hierarchy process. We call that hierarchical decision model. It really is built on quantifying expert judgments. So what we do is we form expert panels at different levels. For example, we have executives at this level, and people who are more energy saving focus on this level, program development and market experts in these levels. So there's several expert panels, each having from 5 to 10, sometimes more members. And what they do is they compare 2 items at a time and assign 100 points or distribute 100 points between them. So when do that for all elements here, right? And then we get those basic values, we run them, we look at all different variations so that we can calculate the inconsistency and disagreement, and so that we could have robust measurements. So while doing that, we basically came up with these numbers. It's interesting to see that the benefits and program and market aspects have equal value. So it's 50-50 almost, right? And then we looked at the programs to evaluate and basically rank them based on our model. And then we ran some scenarios. So the good one aspect of these models is when the priorities change at the higher level, like it happened here in the US, for example, when the administrations changed, you can look at and see which then programs will be more valuable for your region. So that's why these models are universal and can really go from one region to another, as you can see. Now, so the second one looked at this time regional technology planning again, and similar fundings. And this time we looked at the diffusion potential assessment of these devices, meaning, so remember we talked about market diffusion. So we looked at whether or not the market is ready and what needs to be done in the market. So I'll just go to the technology cases here. We looked at, in this case, water heaters, different kinds of water heaters. And here's our model. So as you can see, the market aspects, we looked at consumers benefit, technological, economic types of factors. And then these are our desirability curves. And here's basically what we calculate. So what this tells us, so this is important, the market diffusion of, for example, one ductless heat pump is at about 15%. So there's 85% of work that needs to be done. And by going back to the desirability curves, and we can look at where we are with respect to each technology, then we could tell the regional players what to do from a supply chain perspective or incentives perspective so that the technologies can basically go forward. Now, so these are some examples of the, let's say, scenarios where we can improve each one of these diffusion perspectives by changing some of these, for example, accessibility, improving that, or energy price that will help the diffusion of these technologies. Now, another one looked at this time the energy from a retrospective way, and we looked at the adoption of wind energy, and instead of looking at technologies this time, we looked at policies. Okay, so meaning you're not going to have any transformation itself. So technologies are technologies. It basically you need, like I said, actions in all these perspectives. So one of the very important aspects is policy. So you need to put policies in place that will help economic feasibility, that will have community support, regulatory, environmental, and technical system improvement. So this model looked at that, and we basically looked at how this worked out for wind in the Northwest. We calculated the values. So as you can see, economic feasibility was the most important, followed by regulatory implementation concerns. And through the values we identified, we basically found that renewable portfolio standards, which really means that the region sets goals. For example, they say by 2025, we will reach 50% renewable energy, right? So those really were the important ones. But when we looked at them more closely, we see that regulation incentive standards really had all very equal weights, meaning when you're really trying to transform an industry, let's say in this case, power, you really just work through multiple policy tools, regulations, incentives, and standards, all at the same time. So again, these are some scenarios we ran, and then it shows you that the same policies are leading in most of the scenarios, but there are some changes, so that it helps us to see what we need to do in those examples. Now, I'll just go back real quickly. I forgot to mention the names. I always do that. So this one was conducted by Dr. Abu Taha. She's now a professor in Saudi Arabia. And this one, the second work was conducted by Dr. Momtaj Khanam. She's now working as a software development manager here in the Portland area. And both were my students, and I'm very proud of them. And the next one is, again, another dissertation. Let's go to that real quickly here. The Rnd Project Evaluation, and this was conducted by Dr. Edwin Garces, and he looked at how this is done in regulated utilities where there is really the nonprofit, for example, right? So it's very much similar to foundations where, again, they need to also acquire technologies. So we basically developed this model, again, very similar perspectives, and we're able to evaluate the technologies for the utility sector. Now, evaluating, again, these models, as you can see, can help us to make evaluations at different aspects of the digital transformation. Now, when you have the technologies, when you develop the technologies, you should also be able to acquire them, transfer them, right? So this study looked at the technology transfer potential What is happening in the digital transformation today is, especially at the R&D level, right? There are a lot of R&D proposals, and these are here in the U.S. They go to, public R&D we're talking about. They go to agencies like National Science Foundation, National Institutes of Health, or Department of Energy, and they are generally evaluated using technical criteria. Now, however, they do not, for example, evaluate them for technology transfer potential. And what happens after these technologies are ready, there are challenges in transferring them, finding them a place. Now, that's why we developed this model to come up with a technology transfer potential score, so that when an R&D proposal is given, you can also have a score and an assessment of the technology transfer potential. So we went through the same basic steps, and then we looked at these 3 different R&D proposals, and then we identified where they are. And again, we identified that they are either at 37 and 47%, and we were able to provide feedback to the proposers that would help them to go from, for example, 37% to 50%, so like 33% increase, so that the R&D proposal or the project will have better success in technology transfer. Now, this project, the one that I just went through, was conducted by Dr. Judith Estep, and she's now the Chief Technology Innovation Officer at Bonneville Power, which has funded a lot of our work in the past decade and a half. Now, the next work was looking at this time the technology transfer capabilities of an organization. And Dr. Zhao Lavoie has conducted that. She is now at Daimler, basically Daimler-Benz here in the Northwest. He basically looked at the organization as a whole and how good they are at transferring technologies. And he looked at the Bonneville in this case, of course, and he was there from the day one of his PhD work. So he was working for my research project there, and then was able to observe what was happening. So we were able to use, as a result, action research to identify some of the criteria in addition to literature and also working with the experts, right? And then went through the similar steps, identified the weights and measured, in this case, Bonneville Power, and identified how they can go from 32 to 45 and 62%. So again, these scoring models really help us, thanks to desirability curves, to provide improvement paths, right? And the last project here in the energy, I'm going to talk about robotics technologies. Now, robotics technologies, this was really a combined effort. This was not based on a dissertation, but a funding. We work with Electric Power Research Institute, and they really represent the whole utility sector in the US. And they were interested to find out which robotics technologies had the highest value for them. And robotics technologies, these are some pictures here. They are snake robots, the wire robots, or the submersible robots, or the wall crawling robots. And these are basically going into the places where it's very difficult, like going into the nuclear reactor or transmission lines or the dams and underneath the dams over the walls. So we looked at these to find which one has the highest value. Now, all along on all of these projects, of course, we use experts, right? So how do we find the experts? And it's important that you have the right experts, because if you don't, then the whole evaluation is really, it doesn't have any value. Now, I'm going to back up a little here, so tell you more about the methodology. Now, the methodology is really for decision making. So if the assessment is a global one, you need to use global experts, right? Now, if the decision is within your corporation, you can really work with experts in your corporation. Now, you could say that this is really a theoretical model. It doesn't have practical experience, and I would tell you you're very wrong. I was at a parents meeting. That's funny. At about 10 years ago, and somebody asked me, okay, what do you do? And I said, okay, I'm a professor, so teach classes. And he kept asking, what do you teach? I said, well, decision making, right? And then he kept asking about methods and whatnot, and then he knew about these methods. And he had a consulting company, and he's been working for departments of transportation, states, national in different countries, and helping them with this model select which designs they have to, either for highway construction or for information technology systems. And they had these Excel-based models which they used in other projects, and they were able to really adopt them, like I said, for others. And they were making a lot of money, and they grew up significantly in the last decade. So military uses them for, again, selecting different kinds of systems, vehicles, vessels in the Navy. So the models approach is very, very profitable if you're in the consulting business. Now, like I said, finding experts is key. So in our projects, we were, of course, working with the companies, the organizations, and people they know. And in addition, what we were doing is we were looking at patents and papers, bibliometrics, and conferences, and to look at who is publishing in those areas. We call that bibliometrics and patent analysis, and then putting them into what we call social network analysis, like the ones here, and putting them on graphical display, like you see, and finding those experts who are in the middle of their expertise area, cited most by others, so that we can go to them and ask for their opinion about these different technologies, right? So we did that for this case. We basically went through the same steps, identified the weights and our desirability curves, and found the values for different robots, right? Now, are we done here? Not really. So we want to understand these are where these technologies are going to be in the future. So these are current values, okay? So the following approach was really developed at PSU by, again, by Gertzri, who is now in Bangkok, Dr. Gertzri, and Kokaglu. And what it does is, by working with these experts who are developing these technologies in their labs, we were able to find where these different parameters will be in the future. And by using our desirability curves, we were able to come up with the values going into the future, as you can see here. Now, what this tells us here is that a technology which is at a lower value today can be at a higher value in so many years from now. Now, but what does that do for us, right? Well, it has a very high value for executives. So they can actually make investment decisions today and bring in those investments into the future. So meaning increasing investments in those technologies that will then be at a higher level sooner, right? Because this basically assumes that at the same level development, they will be there. But if you increase your investments into that, you will realize these sooner. Now, of course, the different organizations in different sectors might have different priorities, from functional to design or technology user experience. So if they change, the values change, as you can see here. And that really helps executives to really brainstorm and decide what they should do. Now, This was all about energy. Now, the models are applicable in many other areas. Now, let's look at health and medicine. Now, and this is where we talk about a lot of information technology. Now, this was conducted by Dr. Hogabaum. She was also one of my doctoral students and published here in Health Policy. And this work was funded by OHSU, wearable products, right? In the neurosurgery and orthopedics, the patients, after their surgery, they are monitored, or they need to be monitored. And for that, they keep coming back to office a lot. Actually, they used to before all this pandemic, of course. And what basically the idea here was how can we evaluate these different wearable products, which will basically prevent them from coming back, and they will be able to monitor them remotely. Now, the stage where this decision is made at the end of the evaluation cycle, meaning there are a lot of candidates in the beginning, so there's a lot of technical evaluations, okay? And then when we have, let's say, 5 candidates which do everything we need, we look at which one can be adopted faster by both patients and physicians, right? So these were some of the, these were the 4 products we looked at for this application. And in this case, of course, you have a little bit different perspectives, such as patient perspective, which had the highest, of course, value. And then we looked at different scenarios where these perspectives might have different values in different regions, and which basically technologies then will be the leading choice. Now, very recently, we looked at, again, another type of remote monitoring. This time, Dr. Hamad Alanazi did that, so he's now with a professor here, professor in Saudi Arabia. And he looked at the senior population, meaning old population, and what it takes to have them adopt remote monitoring. And we did this study during the COVID-19 pandemic, so really done through the spring of last year. So it was interesting to see the adoption really happening during that time and validating some of our results. So I'll just come to the model. As you can see here, the model we this time looked at, some of you might be familiar, we incorporated the technology acceptance model here as well, and looked at the barriers that is impacting the adoption of this teleconsultation specifically we looked at by the patients, the senior patients. And then we looked at what would remove these barriers: training, education, government support, et cetera, et cetera. And then basically we, as you can see, we calculated, we have found really that licensing, multi-state licensing was really important, as well as training, and the highest was really financial, meaning standard processes for reimbursement. And we have seen that, so it's interesting, the health information technology has been out there for a long time. And we've been looking at it since almost early 2000s. And it's been really difficult diffusing in the health care system. However, when the pandemic happened and these organizations did not have another option, this was very fast. And what enabled that was financial investments, so that's really coming out in this model too, as well as regulations, like letting physicians basically work in different states through information technology. So the model was really validated through that. Now, We looked at, of course, other areas, and this is very much also relevant. I mean, we did this back in 2015 timeframe, and Dr. Leong Chen was involved with it. Again, like other studies, this was also published in a very good journal. And Dr. Chen is now at Pacific Lutheran University. He's a professor there. And we looked at China and how China should develop pharmaceuticals. Okay, now it's interesting that we looked at the biopharmaceutical industry, and a lot of these technologies have been involved in really the development of the vaccine that we are seeing being approved today. So from that perspective, it was relevant, really. It's still relevant. And what we did, we looked at is we didn't really evaluate which technology should be the winner here, but how can China develop this technology? Should they develop it right in China with their own resources, or imitate, or collaborate with others, or just transfer it from somewhere else, right? And then what resources they should use. So as you can see, the model can be expanded to different levels. And in this case, we developed an Rnd strategy development model. And again, we basically took these technologies from listings of UN and other agencies. We just did a high-level assessment and then looked at the strategies. In this case, it was interesting, although China at the time was going for indigenous innovation, imitative innovation was much higher preferred, and the small and medium enterprises was preferred instead of the state-owned enterprises, which China was trying to really foster. But the model was really useful to tell us what development strategy and what resource alternatives we should use for different types of pharmaceutical, in this case, biotechnologies. And it is very, again, useful in today's case as well. Now, applications in infrastructure. So infrastructure has different elements. In this case, we looked at information technology standards. And Dr. Neshati looked at it. He was working for Intel Corporation at the time, and this was published in another very important journal. And what we really looked at is the challenges that is happening because of the information technology standards, really. What happens is when companies get together, for example, for USB, for HDMI, or for Bluetooth, whatever standard we have for information technologies today, they work together, they share their intellectual property, and sometimes either knowingly or unknowingly, most of the time, these IP leaks into products of each other's technologies, which may then lead to a lot of legal challenges later on. As you can see, these are a lot of different legal challenges that was happening at the time. So we developed a model that is really looking at the decision whether or not a company should enter into a standards body, right? So you can either, the decision here is don't join. You can join but exclude your intellectual property, join and monitor, or join and drive the whole thing, right? And then we looked at, in this case, Intel, and we looked at a general case at the time, and also a retrospectively USB development about 20 years prior to that by Intel and its partners, right? And in each case, the joining and driving came out the decision for Intel for reason that is listed here, because the strategy, market expansion, product alignment, I mean, these are really very important in technology standardization. So for those reasons, Intel had to lead the development of USB, and they did it at the time. And then over the years, we saw that IP licensing became more important as of course, the industry, the IT industry had matured and started to look at the legal issues much earlier. Now, infrastructure is also, or can include science and technology planning. So we recently again did another study which was published and sponsored by National Science Foundation to actually develop a model for National Science Foundation to evaluate their research centers. So specifically, we looked at a program called IUCRC, so Industry University Collaborative Research Centers. And there are about 65 of them in the US today. And what they are is they are really multi-campus centers. So there's several universities coming together, working with their industry partners paying for the research, and NSF really putting their stamp on it so that that verifying that this is a really a center which helps transfer technology, and in that way technology is transferred from academia to industry, right? So NSF had certain objectives, so we worked with the director to develop the model really from their playbook, and help and work with the director of the CIS program to come up with the weights at the higher level, and other program and center directors for the criteria, the factor weights. And then we developed, we picked the centers to look at. As you can see, in this case, we looked at 6 centers, changing from information communication to energy to advanced materials. And as you can see, there are multiple universities in each case. And then we developed our model. We developed the desirability value curves, and we're able to calculate, for example, in this case, the value for a center at, let's say, 59%, right? So we did that for all of these 6 centers. Now, what we can do with these values is identify weaknesses of centers and tell them what to do. So in this case, for example, and we also have to tell them where the biggest bang for the buck is. So meaning which criterion has the highest weights. In this case, for example, student topics, research projects have really high values. And then when you look at these centers, right, they really did very bad in these areas, and they can do better, right? So by focusing on just student topics, these centers, 3 centers, can really increase their values. And we did that. We looked at, for example, these different centers here, told them what to do in these areas, and they were able to, or in theory, go from 63 to 71% in one case, and 52 to 63% in another case. Meaning, NSF can use this model to evaluate these centers and tell them where to improve. Now, a recent one, and the prior one, was done by Elizabeth Gibson, Dr. Gibson. She is now a professor at the University of Colorado, Boulder. This current one was done by Dr. Barham. He is now working at Amazon in Seattle. Again, we had this also published in a very good journal recently. And we looked at this case, the big data implementation. Now, as you can see, as you might have heard, a lot of cities around the world are trying to be a smart city. And of course, that happens with implementation of big data projects. And like the of ERP at the time, we have seen a lot of failures, right? Organizations had been failing in adopting ERP at the time, and the same thing is happening at the cities now. because they haven't done that before. So we developed a model to look at, once they select the technologies here, select the projects, and before they start the projects, are they ready, right? And we developed this model which looked at readiness at people level, technology level, legal level, organization level. And for example, in the people level, the data scientists, employees, technology skills, management, analytical skills, these were important. And then when we went through, we really found that the people aspect was the most important in readiness in this case. And within that, data scientists and public acceptance were really high. And then we looked at these 4 projects, traffic safety sensor project, air quality sensor testing, and others, really making our cities smarter, if you will. And then we applied our model, and we showed them, as you can see, the values, and then how they can really go from improve by really, for example, hiring skilled software team that can handle various complexities, utilizing a data scientist from a local university, and so on and so forth, so that they could improve really their readiness. And that's what it is really helping them to improve their readiness. Now, a few applications this time in project management. Now, project management is an important tool in really transforming, but this time this is really looking at the highway transportation and construction of highways. And again, this is an area where the highway construction can also, like tools such as value engineering and whatnot. We evaluate them to model and provided feedback to these companies. So he's gone back to Libya to really help the Libyan government. Wanted to show you different sectors and different basically applications to show the versatility, the really diversity of this tool. We were able to use that in that area as well and provide, in this case, feedback. And for example, offshore area in oil and gas, political aspects is important. As you can, you guys are very familiar with this, with what's happened in the Mediterranean, right? So political aspect is really important in choosing where to do this evaluation, because there's a lot of conflicts over maritime claims, and this was validated with the recent events in the East Mediterranean. All right, so this really brings me to the end of my discussion today, which, as you can see, you can apply these models to evaluate technologies at every level, at every sector. And in digital transformation, and it's happening everywhere. It's not just the buzzwords. It's as you can see, from energy to healthcare, information technology is intersecting. And during the last pandemic, we have seen that that's happening much faster and significantly. We have other research projects that I haven't gone through, which we use, which we basically implemented technology acceptance models and run adoption, run surveys, and found, for example, during the pandemic, we looked at the adoption of student information systems, which happened. Education is now happening on through basically IT, and seeing that again, we have to pay attention to multiple perspectives all around. So it's important to understand multiple perspectives, and of course, this specific exercise we use in these models help facilitate communication, consensus, and agreed upon plan. So with that, I stop presenting, stop sharing, and open for questions.
Evet, hocam çok teşekkür ederiz sunum için. İlk önce şöyle bir şey sormak istiyorum. Soruları Türkçe alabilir miyiz acaba? Sizin için de bir sakıncası yoksa biraz daha sohbet havasında geçmesi için.
Olur ama ben İngilizce cevap verebilirim.
Tamamdır. Arkadaşlar o
Bu
zaman
konuda Türkçe konuşmaya çalıştım bir kere. Hatta onu keynote'da yaptım Boğaziçi Üniversitesi'nde. Terimler ve benim deneyimim İngilizce olduğu için
evet.
o zaman zorlandım. O yüzden İngilizce daha iyi yapabilirim.
Tamamdır. Arkadaşlar sorularınızı chat kısmından sorabilirsiniz. Bu arada bir ekran görüntüsü almak istiyoruz ama müsait olan arkadaşlar da kameralarını açabilirse Pamir bir screenshot alacak. Pamir orada mısın?
Bir saniye ben
Tamam.
halledeceğim. Şunu. Bende tam gözükmüyor. Tuğrul Bey sizin kameranız açık mı şu an? Bende gözükmüyor ama.
Açık. Atakan sen görüyor musun?
Ben de
sen al.
görünüyor. Bende de şu an sadece Baran görünüyor.
Tamam ben hallettim. Ben
Tamam
hallettim.
mıdır?
Teşekkür.
Tamam.
Evet hallettim.
Tamamdır. Teşekkür ederiz. Sorular varsa alabiliriz arkadaşlar.
Saat kaç oldu orada? 9 mu oldu?
Evet.
Evet, şu an 9. Tuğrul Bey, ben konuyla biraz bağımsız olarak bir soru sormak istiyorum ama
Hı hı.
şimdi siz Amerika'da da okudunuz, Türkiye'de de okumuş birisiniz. Ben birazcık şeyden bahsetmenizi istiyorum. Oradaki üniversitelerin ve buradaki üniversitelerin farkları nelerdir? Yani birazcık üniversiteleri karşılaştırabilir misiniz? Bir de mesela burada okuyan öğrenciler, şimdi Amerika'daki üniversiteler tabii ki kat kat daha iyi kalite bakımından. Ama buradaki öğrencilerin oradaki öğrencileri yakalayabilmeleri için neler yapmaları gerekir? Veya üniversitenin başında olan birinci sınıf öğrenciler için neler önerebilirsiniz? Yani üniversiteyi nasıl dolu dolu okuyabiliriz? Birazcık bunlardan bahsedebilirseniz çok sevinirim ben.
Tabii benim cevabıma çok dikkat etmem lazım. Çünkü politik bir soru bu. Türkiye üniversitelerini Amerika'daki üniversitelerle karşılaştırmak. Sonra başım derde girebilir. Şimdi ben Türkiye'den 1989 yılında çıktım. O zamanki üniversitelerle şimdiki üniversitelerin alakası yok tabii ki. Benim çıktığımda özel üniversite, yani ben zaten üniversiteye girdiğimde özel üniversite diye bir şey yoktu Türkiye'de. Ben üniversitedeyken ilk defa Bilkent Üniversitesi kuruldu. Sonra yıllarca bir dolu üniversite kuruldu. Tabii şöyle bir şey var. Türkiye diğer gelişmiş ya da gelişmekte olan ülkeler, sonra gelişmiş ülke seviyesine çıkan ülkelerin geçtiği yoldan geçiyor. Mesela Kore'de bu açılım başladığında birçok üniversite kuruluyor aynı Türkiye'deki gibi ve bir enflasyon, bir kalite düşüklüğü oluyor birçok üniversite. Yani kurulan bazı üniversitelerde ve ondan sonra daha kaliteye önem verip mesela Seoul National Üniversitesi'ni kuruyorlar. Çünkü bilim adamı yetiştirmeye önem vermek için. Türkiye'de de bu oluyor. Mesela TÜBİTAK daha etkin, daha ne derler, üniversitelere dikkat ediyor yıllar içerisinde. Onu gördüm. Tabii üniversiteler de, yani bir Sabancı, bir Koç Üniversitesi kuruldu, Özyeğin Üniversitesi kuruldu, Yeditepe Üniversitesi, Bahçeşehir Üniversitesi. Yani benim zamanımda işte bizim teknik olarak bildiğimiz Boğaziçi Üniversitesi, İTÜ, ODTÜ, Yıldız Teknik vardı. Şimdi İstanbul'da bir dolu üniversite var. Tabii onun dışında bir dolu tam ne olduğunu bilmediğim üniversite de var. Yani mesela İstanbul'a yıllarda gidip geldiğimde işte çevre yolundan gittiğimizde bakıyorum bir apartman üstünde üniversite. Yani apartmanı olan neredeyse üniversite kurdu gibi bir şey oldu. Tabii bu sonuçta benim gördüğüm oradaki meslektaşlarımla konuştuğum gibi bir fakülte ya da öğretim üyesi olmayan, yani kaliteli olmayan veya bulunamayan üniversiteler var. Çünkü o kadar yetiştiremiyoruz. Onun yanında çok iyi dünya çapında yani benim de ilk saydığım üniversiteler Yeditepe olsun, işte Bahçeşehir, Boğaziçi, hala Koç, Sabancı, bunlar dünya çapında üniversiteler oldular. Değişti tabii. Yani benim zamanımla şimdiki arasında çok fark var. Aynı kalite farkları Amerika'da da var. Yani üniversite var. Amerika'da 6-7 bin tane yüksek öğrenim enstitüsü var. Yani bunların hangisi daha iyi, hangisi daha farklı ve hepsi ayrı ne derler, dallarda. Şimdi senin sorduğun oradaki öğrencilerle buradaki öğrenciler, yani öğrenciler her yerde iyi öğrenci var, kötü öğrenci var. Ve eğer bir öğrenci kendini geliştirmeye çalışıyorsa o her yerde başarılı olacaktır benim kanımca. Tabii ki başka bir açıdan eğitim görmek her zaman yararlı. Yani orada bir eğitim gördükten sonra başka bir yerde öğretim görmek tabii faydalı. Şimdi benim zamanımda işte geldiğimde biz o zaman bizim zamanımızda internet diye bir şey yoktu. E-mail diye bir şey de yoktu. Biz mektup yazdık üniversitelere. İşte bir ay sonra onlar bize mektup yazdı. Öyle ne derler, bilgi edindik. Şimdi siz oradan yani böyle bir bilgi edinebiliyorsunuz. Her şeyi görebiliyorsunuz. Biz o zaman bizim kütüphaneye ayda bir tane Hürriyet geliyordu. Biz bir ay evvelinin haberlerini öyle okuyorduk. Tabi o zaman da diyorduk ki ya bizim hocalarımız, o zaman Amerika'da olan Türk hocalarımız işte gemiyle gelmişler. Bak biz uçakla geliyoruz. Herhalde ileride de uzay gemisiyle gelecekler. Ve ne yani demek istediğim o zamanla bu zaman çok değişik. Şimdiki yani orada görünen eğitimle buradaki eğitimin pek farkı yok bence. Çünkü aradaki fark kapandı bu bilgi teknolojileri sayesinde, bilişim teknolojileri sayesinde. Ama her zaman farklı bir perspektif bence önemli. Gelip burada okuyup buradaki toplumu görmek, ondan sonra Avrupa'da bir toplumu görmek. Mesela ben o yüzden kendimi geliştirmek açısından dünyanın değişik yerlerinde bu böyle konuşmalar yapıyorum, dersler veriyorum. Mesela Almanya'da 12 yıldır bunu yaptım. Rusya'da yapıyorum, Finlandiya'da yapıyorum, Tayvan'da, Kore'de. Şimdi Türkiye'de başlıyor. Türkiye'de hep yaptım böyle eğitimler de şimdi daha uzun süreli şeylere derslere başlıyorum. Bu bana mesela buradaki değişik enstitülerle yapıyorum. Bir büyüme ve öğrenme e, ne derler, imkanı sağlıyor. Aynısını tavsiye ederim. Yani hepimiz kendimizi geliştirmemiz lazım. O yüzden imkanlara bakmak lazım. İmkanlar çok. Dışarıda üniversitelerde ne derler, Türkiye'de olan burslar. Tabii ki şu anda dolar, lira ne derler, paritesi çok kötü diyelim. Fakat benim zamanımda da kötüydü o zamanın şartlarıyla. Mesela bir gecede 4'e katladı dolar vakti zamanında. Yani böyle şeyler oluyor. Ama bu çareler de bulunabiliyor buna. E, Sayın rahmetli Demirel'in dediği gibi demokrasilerde çareler tükenmiyor. Tabii bilmiyorum sizler bunu bilebiliyor musunuz? Bizim zamanımızdan kalma terimler bunlar. İmkanlar çok. Mesela benim zamanımda olmayan, şimdi Avrupa'da çok imkan var. Avrupa'da, Asya'da birçok ülke Amerika'nın modelini kendine aldı. Yani beyin göçünü kendine almaya çalışıyor. Ve birçok burs veriyor. Mesela Tayvan'da, Kore'de, Rusya'da gördüm bunları. Almanya'da çok var. İngiltere'de var. Almanya'da güzelliği bir de çoğu yerde eğitim İngilizceye dönüştü. Ve çoğu yerde parasız. Almanca biliyorsanız çok rahat oluyor bu. Ama Almanca bilmiyorsunuz, özel okullarda İngilizce ve burslu olabiliyor. Ve bunun bursunu da genelde endüstriden sağlıyorlar. Yani böyle imkanlar var. Bence bütün bu imkanları kullanıp kendinizi geliştirin. Yani Türkiye'deki eğitim aşağı veya yukarı değil. Benim şeyim değişik perspektif her zaman iyi.
Evet, çok teşekkür ederim. Güzel bir cevap oldu benim için. Pelin arkadaşımızın bir sorusu olmuş. İsterseniz ona bakalım. Evden çalışmaya sıcak bakmayan kurumsal şirketler pandeminin ilan edilmesiyle büyük oranda home office çalışma kararı aldı ve bu sistem başarılı oldu. Bu olay dijital dönüşümün hızlanmasında büyük rol oynamış gibi duruyor. Ancak her şey normale döndüğünde eski sisteme geri dönmeye hevesli duruyorlar. Sizce kurumsal şirketler gerçekten dijital dönüşümü destekliyor mu diye sormuş.
Şimdi şöyle bir şey. Ama çok tabii size ne kadar yabancı gelecek. Şöyle bir cevap vereyim. Ben kaç yaşındaydım? 12-15 yaşındayken biz o zaman televizyonumuz siyah beyazdı. Saat 7'de başlardı, 12'de biterdi ve böyle science fiction, bilim kurgu film seyrederdik. Filmde 2000 yılında geçerdi. 2000 yılı çünkü çok ileride bir yıl. İnsanlar hepsi gri, parlak kıyafetlerle dolaşırlardı ve yemek yemezler, hap içerlerdi. Şimdi öyle olmadı, değil mi? Veya Jetgiller mesela vardı. O zaman siz bilmezsiniz çoğunuz. Bizim yani yarım saat çizgi film vardı saat 7'de. Onu seyretmek için ölürdüm. Jetgiller, her şey uçuyor falan filan. O da olmadı. Hala yürümeyi seviyoruz. Güzel kıyafetler giymeyi seviyoruz. Restorana gitmeyi seviyoruz. Dediğim robot olmayacağız. Yani birden her şey hani dijital transformasyon, bize dijital böyle dat gitmeyeceğiz. Yani hep beraber bir restorana gitmek hala olacak. Ne kadar her şeyi Amazon'dan veya işte gitti gidiyordan nereden alıyorsak gene çıkıp alışveriş etmeyi, mesela ben ne zaman gitsem bir Bağdat Caddesi'nde dolaşmayı severim. Niye bunlar? Çünkü biz insanız. Yani hep anlattık anlattığım şeyde de. Multiple perspektifler var. Sadece teknik değil, bu işin social aspekti de var. Yani tabii ki evden çalışma oluyor. Daha evvel de oluyordu. Benim eşim Intel'de çalışıyor. Ben Intel'de çalışıyorum. Mesela geliyor saat 3'te, akşamüstü geliyordu. Sonra yemeğimizi yiyorduk. Ondan sonra saat 7'de Hindistan'la bir toplantıya giriyordu falan filan. Veya bazı günler evden çalışıyordu. Yani bu olacak, daha da oluyor. Fakat beraber çalışmanın faydaları var. Niye? Sosyalleşiyor. Yani biz insanlar sosyal hayvanlar. Sosyalleşmeden olmayacak, değil mi? Sosyalleşmemiz lazım. Ondan sonra eğitim. Şimdi eğer eğitim tamamen böyle olursa o zaman ne olur? Üniversitelerin hepsi topu atar. Sadece bir iki tane üniversite kalır. Çünkü online yapabilirler. Ama ne özelliği var eğitimin? Hep beraber bir sınıf içerisinde olduğunuz zaman biz dediğimiz network oluşuyor, değil mi? Networking yapıyorsunuz, beraber tartışmaya giriyorsunuz. Onun değeri eğitimin yarısı. Eğer o olmazsa o zaman dediğim gibi üniversiteler topu atar. O değeri de bulamazsınız. Yani ne öyle ne böyle olur. İkisinin gene karışımı, hibriti olacak. Biz teknolojiyi kullanmamız lazım. Teknolojiye köle olmamamız lazım. O yüzden teknoloji yönetimi çok önemli. Bizim teknolojiye köle olursak, mesela Wall-E diye bir film vardı. Sizin kuşağınız onu daha çok iyi bilebilir, bir çizgi film. Wall-E'de insanlar dünyayı mahvetmişler. Hepsi uzayda yaşıyorlar ve hepsinin autonomous vehicle'ı var altında. Her şey, yemekler geliyor gidiyor ve hepsi tabii ki böyle olmuşlar. Öyle olmamamız lazım. Öyle olursak insanlık ölür. Bir benzeri de bilmiyorum, okudunuz mu? Biz ortaokuldayken okumuştuk. Time Machine, zaman makinesi H.G. Wells'ın. O da enteresandı. Teknolojiden devamında insanlığın bir kısmı basically hiçbir işe yaramayan, meyve toplayan bir cins olmuş. Bir kısmı da öcü gibi onları yiyorlar. Yani teknolojiye köle olmamak lazım. Çok ne derler, insanlık tarihine gidip bir cevap verdim. Fakat ben zannetmiyorum yani dijital transformasyon demek hepimiz dijital olacağız demek değil. Yani entegre etmemiz lazım bunu, adapte etmemiz lazım. Hayatımızın bir parçası olacak ama biz gene yaşayacağız. Yani gene çıkıp yürüyeceğiz. Bir sahilde yürümek, bir boğazın havasını almak hala bizim bir şey ne derler içimizde. Yani hala özlediğim bir şey. Ne zaman bir vapura binip boğazı geçmek mesela. Kadıköy'den Karaköy'e gitmek. Tabii belki biz yaşlandık. Biz hala onu seviyoruz. Siz onu sevmiyorsunuz. Belki ne derler diğer kuşaklarda bu oluşacak. Bunu da göreceğiz.
Evet hocam. Başka soru yok gibi şu anlık. Arkadaşlar soru varsa alalım. Yoksa yavaştan kapatabiliriz. Size çok teşekkür ederiz. Vaktinizi bize ayırdığınız için.
Ben çok teşekkür ederim. Beni davet ettiğiniz için.
Evet.
Umarım sizi yüz yüze de ileride görebilirim.
Evet, inşallah başka etkinliklerde görüşürüz. Çağla hocamız da çok teşekkür etti size. Çıkmak zorunda kaldı o. Küçük bir işi vardı. Onun da teşekkürlerini ileteyim. O zaman kapatabiliriz. Arkadaşlar size de çok sağ olun. Sizler de çok sağ olun. Etkinliğimizi bizi yalnız bırakmadığınız için. Başka etkinliklerde görüşmek üzere. Herkese iyi akşamlar o zaman.
Allah'a ısmarladık.